Welcome. In today's video, we are going to start looking at Chapter 4, which deals with reactions in aqueous solutions. So this actually covers a lot of different things. We'll talk about electrolytes today. We'll talk about acids and bases, redox reactions, solution concentration. So we'll go back through molarity, and that will also tie into stoichiometry. So we'll be able to do some more stoichiometry equations with molarity calculations. To start with, we're going to do a little bit of basic review for solutions. So an aqueous solution is a homogeneous mixture of two or more substances. So if we have an aqueous solution, it's going to be water-based. So water is the solvent and the solute has been dissolved, so therefore it is homogeneous. Also, as a review, need to go over solute and solvent. So solute is what you are adding into the solution. It's the part that's getting dissolved into the solution. So for example, salt in salt water, salt would be the solute. Sugar in soda would be dissolved into the solution, so that would be the solute. Or also carbonation, carbon dioxide in soda is dissolved into the solution, so that's the solute. Solvent is the part that is doing the dissolving. 98% of the time, that is going to be water. So water is going to be our main solvent. So if we have salt water, water is the solvent. In soda, water is the main part. It's the main medium. So that is also the solvent. All right, you might remember in Regents chemistry when we did the conductivity lab. So we had the little light bulb with the two electrodes and you put it in the different solutions. If it was a good conductor, it lit up brightly. If it didn't conduct well, it lit up either very dimly, or if it didn't conduct, it didn't light up at all. So the solutions that conduct are electrolytes. So an electrolyte is a substance whose aqueous solution will conduct an electric current. So once it's dissolved in water, it will conduct electricity because the substance dissociates into positive and negative ions when it's dissolved in water. So it's those ions that are capable of carrying the electric current. So in order to conduct electricity, you need free moving charged particles. So in a solution, that would be free moving ions. So in an aqueous solution, if you have something like salt, it will dissociate into the positive and negative ions, and it's those ions that allow it to conduct electricity. A non-electrolyte is a substance whose aqueous solution does not conduct electricity because it does not produce ions when it is dissolved in water. So electrolyte, when dissolved in water, conducts electricity. Non-electrolyte does not. Electrolytes are acids, bases, and ionic salts. So in reagents, we said ABS, so acids, bases, and ionic salts. So on the previous slide, we mentioned dissociation. So dissociation is when you have a substance that dissociates, splits apart into its positive and negative ions. So in this picture, we can see that we have sodium chloride, and it is then are free to move throughout the solution. Now, one thing that we need to mention is that dissociation and solubility are not the same thing. So salt does dissolve in water. Salt also dissociates when it hits water, meaning that it breaks apart into its ions. Sugar is soluble in water. If you add sugar to water and stir it, it will dissolve. But sugar does not dissociate. Sugar does not break apart into ions because it's not ionic. So dissociation and solubility are not the same thing. That can get a little bit confusing. All right, so back to electrolytes. So electrolytes, when dissolved in water, they conduct electricity. So we can see by this diagram here, it's got a conductivity tester like what we used in lab with the light bulb and the electrodes. A strong electrolyte is something that completely will dissociate when dissolved in water. So a strong electrolyte would be something like this here. The light bulb lights up brightly and it has many ions present in solution. A weak electrolyte dissociates partially when dissolved in water. So if we look at this middle diagram, the light bulb is lit up a little bit and we get a few ions, but not all ions like we got with our strong electrolyte. And then lastly, we'd have a non-electrolyte. The light bulb is not lighting up and there also are no ions present, so it's not conducting electricity. Again, our strong electrolytes are our acids, bases, and ionic salts. But to be a little bit more specific, we have 7 strong acids. So it's got to be a strong acid, 8 strong bases, and then all ionic compounds that are soluble, that dissolve in water. So we need to know our solubility rules, which we'll talk about shortly. So electrolytes are acids, bases, salts. Strong electrolytes are ones that ionize completely in solution. So that would have to be your strong acids, strong bases. Not any of the weaker ones. Those would be weak electrolytes. So strong acids, strong bases, soluble ionic compounds are our strong electrolytes. So I'm not being very subtle on this slide. I need you to memorize these 7 strong acids. So HCl, that should be easy. HCl is our most common acid that we've ever used in lab. HCl, HBr, HI. HClO3, which is chloric acid, HClO4, perchloric acid, HNO3, nitric acid, and H2SO4, sulfuric acid. We need to memorize that those 7 strong acids, or those 7 acids, are strong, therefore they ionize 100% in solution. All right, our strong bases. Our bases that ionize completely would be the group 1A metal hydroxides. So lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium and cesium hydroxide. The heavy group 2A metal hydroxides, calcium hydroxide, strontium hydroxide, and barium hydroxide. If we take a look at our periodic table, if you go down group 1 and then over and up on group 2, it will make a B. So it helps us remember that those 8 metals, lithium, sodium, potassium, rubidium, cesium, then barium, strontium, calcium, those 8 metals with hydroxide are our strong bases. And we need to memorize that also. So if we have an acid or a base that we know is an acid or a base, and it's not one of those strong ones, it will be a weak electrolyte. So if we have something like acetic acid or hydrofluoric acid, HF, it's not one of the 7 strong acids. It will still conduct electricity a little bit, but it will only dissociate partially. So we will only have some ions in solution, not total ions in solution. So therefore, it would just be a weak electrolyte because they exist in equilibrium together. We will do way more with equilibrium at the end of the year. So the reason why this is important is we need to be able to look at a species and know if it's going to exist in solution as a molecule, like sugar, because it would stay together, or if it's going to exist as separate ions, like sodium chloride is going to exist in solution as separate sodium ions and chloride ions. So we need to know how they're going to exist. That's why we need to know if it ionizes completely or partially or not at all. So if we have a strong electrolyte, that means that it ionizes completely, it dissociates completely. So it would be soluble and ionic. We'll cover solubility rules next. If it is one of the 7 strong acids or one of the 8 strong bases, then it's going to be a strong electrolyte. It's going to dissociate completely and conduct electricity very well, exist all as ions. If we have a weak electrolyte, there will be some ions present. It would conduct electricity somewhat, but it's going to exist as a lot of molecules together and only partially ionized. So if you have acetic acid, a lot of the acetic acid molecules stay together, only a few of them ionize, so you only have a few ions in solution, hence why it is a weak electrolyte and does not light up brightly. If something is a non-electrolyte, then it will not ionize in solution. So that's going to be all of our pure solids, pure liquids, gases, and other molecular compounds. All right, so we are just going to classify these as strong electrolytes, weak electrolytes, or non-electrolytes. So pure water is just H2O. H2O liquid, there's no ions present. It's a covalent compound. So this would be a non-electrolyte. And you may remember from the conductivity lab way back in Regents that pure water does not conduct electricity. Tap water is a weak electrolyte. There are some ions present in solution, but not a huge number of ions present. Sugar solution, so an aqueous solution of sugar would also be a non-electrolyte. We don't have any ions. The sugar will dissolve, but it does not dissociate into ions. Sodium chloride solution. That is certainly a strong electrolyte, which I'm just going to abbreviate, SE. So sodium chloride hits the water, fully ionizes. We have lots of ions, so it would be a strong electrolyte. Hydrochloric acid solution would also be a strong electrolyte. Hydrochloric acid is one of our 7 strong acids, so it will ionize completely in solution, making it a strong electrolyte. Lactic acid. So it's an acid, so it will conduct. It is an electrolyte, but lactic acid is not one of our 7 strong acids, so this would be a weak electrolyte. Some of the molecules will ionize. We will have some ions, so it will conduct somewhat, but not strongly. Ethyl alcohol solution. That's an organic compound. So we have our covalent bonds, not ionic, so this will not conduct. So non-electrolyte, because we don't have our ions. Pure sodium chloride, that would be NaCl solid. That is a non-electrolyte too. Pure solid salt does not conduct electricity because the ions do not dissociate until they are mixed in with water. As a solid, those ions are held together so they are not free to move to carry the electric current. All right, on our last slide, we have an example here. So it says to rank these solutions in order of increasing electrical conductivity based on the fact that the greater number of ions in solution, the greater the conductivity. So we have 4 total solutions. This one down here would be our strongest electrolyte, which means that it would contain the most ions. So let's take a look at our list. We have calcium nitrate. Calcium nitrate is a soluble ionic compound, so this is going to be a strong electrolyte. We have a 1 molar glucose solution. That would be a non-electrolyte. Glucose is a covalent compound. It is not going to ionize in solution. We have 1 molar sodium acetate. That would be a strong electrolyte because we have a soluble ionic compound. So we'll have lots of ions in solution. And then we have acetic acid. It's an acid, so it's an electrolyte, but it's not one of our 7 strong acids. So therefore, it's a weak acid. So therefore, it's a weak electrolyte. So obviously, the glucose is going to have the least conductivity. It would have no conductivity. So our glucose solution would be least, followed by the acetic acid solution, because that's going to conduct somewhat, so it would light up the light bulb dimly. Okay, now we have 2 strong electrolytes. So what we need to think about is the concentration of their ions. So when calcium nitrate hits the water, that will separate out into calcium ions and 2 nitrate ions for each molecule. So for each molecule, we will get 3 ions. So this would give us an ion concentration of 3 molar. So 1 times the 3 ions. Sodium acetate, when that hits the water, that would dissociate into the sodium ion and the acetate ion, so 2 ions. So this would give us an ion concentration of 2 molar. So calcium nitrate has a higher ion concentration, so therefore it is going to have a higher level of conductivity than the sodium acetate would. Obviously, if you changed the molarity of the solutions, then your answer could change.